Hi everyone, myself and Arun Kumar from SNS College of Technology in the Department of ECE. In this video, I am going to share about flip-flops in sequential circuits. So these are all the slides we are going to see in this video: introduction, types of flip-flops, applications, activity, followed by assessment. Introduction. Now, normally the flip-flops are used for a 1-bit storage device. It will be implemented for a lot of application process, especially it has been selected based on the two states, either a set or reset. And moreover, the output has been assigned based on the number of flip-flops. So generally, the output has been represented by Q and Q bar. So the main function of flip-flop is storing the binary data, and the stored data has been changed based on the inputs. Student challenges in flip-flop. The students are little bit confusing the latches on flip-flop, because latch and flip-flop also the same. The only thing is the latch will not execute the a positive and negative edge transmission, while the flip-flop is taking the positive and negative edge transmission. So the concept is the latch has been implemented for the flip-flop, because the latch only provide the set and reset condition to the concerned flip-flops. Why flip-flops? The flip-flop is used for storing the data, as well as it is having a two stable state, either set or reset conditions, and output has been fetched by Q and Q bar, and the state has been assigned based on the number of inputs and previous inputs. SR flip-flop. So the table has been formed based on the concerned truth table. Based on the truth table only, the next transmission state has been formed. The diagram of these SR flip-flop is purely followed by the NAND gates. And if you are giving a input like 0 0 0 1 1 0 1 1, so because 2-bit variation, we have only the 4 combinations, so there may be they given 0 0 0 1 1 0 1 1 like this. Then the condition of this SR flip-flop is Q is previous state, and 0 1 for 0, 1 0 for 1, and 1 1 for not having any answers. So the corresponding state has been represented by no change, reset, set, and forbidden. So the same will be implemented for the next state. The SR also given 0 0 0 1 1 0 1 1 like this they are given. And for QN, the QN is a present state. The present tense has been applied for this input 0 0 0 1 1 0 1 1. So that we can able to implement the QN as 0 and 1 for these all inputs. So finally, we will get the Qn plus 1 is the next state, because in SR flip-flop it's the present state, and while getting the output as a next state. So the next state we need to calculate. The calculation of the next state has been done by the present state of this truth table. For example, if you are applying 0 1 0 means the same value will be implemented for the next state also. For example, 0 1, so 0 1 is 0. So here the value is 0, the Q value also 0. The same will be implemented for next state also 0. 1 1 is a unforgettable state, and we won't redefine the state. So 1 1 0 for 0 also it is invalid, and for 1 also it is invalid. Like this, the truth table has been mapped with the next state of the concerned table. D flip-flop. So the forbidden state has been rectified with the help of this D flip-flop. By using the inverter, we can able to rectify the unconditional state. So the data is given as 0 and 1 is in D flip-flop, then the same value will be comes under the next state. If you are giving 0, then automatically the value will be 0. If you are giving 1, then the next state also a 1. JK flip-flop, same like SR flip-flop, the condition will be varied for this JK flip-flop. For example, 0 0 0 1 1 0 means the same answer Qn 0 1 Qn dash will become. So this will be implemented for this truth table. For example, 0 1 0, so 0 1 0, 0 1 0 means Qn also 0 0, 0 1 0, the next state also 0. 1 1 means Qn bar, so Qn bar indicates if the value is 1, then the Qn bar is 0. If the value is 0, then the Qn bar is 1. Like this we need to implement for this table. Let us consider this one. 1 1 is Qn bar. Then the same will be 0 and 1 is applied for Qn. Then 1 1 is nothing but Qn bar. Qn bar is Qn is here 0. Then automatically the opposite value 1 will be comes in the next state. For example, next state also it will come 1 1. Qn is 1. For Qn plus 1 is Qn bar. So then 1 will be replaced as 0. So like this the table will be filled. T flip flops. So the T flip flops are the same as the D flip flop, but the thing is, 0 is no change, 1 is toggle. Only that value will be mapped for this T flip flop. Applications: digital clocks and door locking system, thermostatic and display machines and dispensing machines also we are using for this D flip flops. The summarize, we can able to mapping the information by using this summarize. For example, if we want to know clearly about JK flip flop means, then we can able to mapping the JK flip flop so that we can able to know the concept clearly. Activity. So think faster. Let us implement a CISO shift register using D flip flops. Take a 5 minutes to think about it, then discuss with partner. Consider shift direction, it either left or right. Hint, connect the input of each flip-flop to the previous stage of the output. Assessment. In Siemens PLCs, which flip-flop is typically applied for designing a toggle operation, such as motor on or off control? The answer is C, T flip-flop, because it will be a toggle operation on or off condition. So either 0 or 1, then we can use for this T type of flip-flops. And second question, in digital watches and timers manufactured by the Texas Instrument, which flip-flop is commonly used in synchronous counters? So the answer is JK flip-flop, because in JK flip-flop only XOR gate will come. 0 1 is 1, 1 0 mean also 1. So that we can use both the signals clockwise. We can use for this type of question. So these are the website I have referred for this video. Thank you.